So for the middle one right here, I'm going to do a u substitution, but what am I going to let u be? Right, x squared plus 4, the bottom. What's the derivative of the bottom? 2x. So if I have a 2 out here and divide by a 2, then I have negative 6. And what type of integration is this? Natural log. Okay, I didn't write down the u equals x squared plus 4. I just recognized that it was a natural log. And now what I have on the bottom, the derivative is up on top. So it's just the natural log of the bottom. And you don't need the absolute values because x squared plus 4 is always positive. Okay, and then we have minus 2, and that's a very easy arctan because u is x, and therefore du is dx. And a is what? 2. So arctan is 1 over a, arctan u over a. Yes. But I have this negative 2 out in front, so negative 2 over 2 is just a negative 1. Arctan x over 2 plus c. Okay, that one actually was probably nastier than the one I said that's as hard as it gets.
Yeah.
I'd say that one was as hard as it gets. Yeah. Okay, that one was pretty bad. You're throwing the long division in there, you have to separate the numerator, and you're using both a natural log and an arctan integration. Okay, I'm going to review one more concept from Algebra 2 and Pre-Cal with you, and that is completing the square. I know. Because, look at number 6. If you just look at the bottom of that, there's nothing on top. So we're thinking, well, maybe we just have to let u be the bottom, but the derivative would be 4x minus 8. And I don't have anything near like that on top. The problem is that it doesn't factor. And 2 is that there is no chain rule for integration. That's derivatives. Okay, so we're going to go over here and complete the square. The way that you complete the square is that the first step is that what's in front of x squared has to be a 1. So I need to factor a 2 out of just the x's. So if I factor a 2 out of the x's, I'm going to get x squared minus 4. And then I'm going to move over and leave a space and close my parenthesis and then put the 14 outside that parenthesis. Harry? 4x, thank you. All right, now to complete the square, we take half of this x number and square it. So half of negative 4 squared is plus 4. Yeah, half it, box it, square it. All right, now if I put a 4 inside the parenthesis here, what have I really put into this expression? 8, because there's a 2 in front of that parenthesis. So if I add 8, I also have to subtract 8. So this is 2 times the quantity x minus 2 squared plus 6. Yeah, the whole point, the reason it's called completing the square is because that middle part factors into a perfect square. And it will always factor into x and then half of this middle term number right here. Or it's what you boxed. Okay, so when we half it, box it, square it, we started with the negative 4. Half of that was negative 2. Box it, and then square it is the 4. So the 4 is what we put into the equation. The reason that Ms. Brooks taught you to box it right here is because that's how it factors. It factors into x and then minus 2. Yeah, or you can just factor it, but that's a nice little trick. Don't be condescending. Okay, so this is really the same thing as 2 times x minus 2, the quantity squared, and then plus 6 dx. Which one of the arctrigs? It's, or yeah, arctrig, arctangent. Well, I meant like which one of the arctrigs is it, and that just really, arctrig doesn't make any sense. Okay, it is arctangent. The only thing that kind of concerns me, though, is this 2 that's right here. Could I factor a 2 out of the bottom? Yeah. Okay, so how about 1/2, and then the integral of 1 over x minus 2 squared, and then what will I have? Plus what? 3. I'm factoring a 2 out, not distributing. All right, so what's my u? X minus 2. Du? Dx. And a is... No, it's going to be a 1/2 outside because I factored the 2 out of the bottom. So the 2 still has to be on the bottom outside. All right, so arctan, I've got that 1/2, and then arctan is 1 over a, arctan u over a. Plus c. Okay. Before I deal with the limits of integration, do we want to just let u be something? Is it an easy arc trig? Or what do I need to do? You cannot take an x in or out of a square root or in or out of a integral. Okay, let's complete the square again. All right. I'm going to rewrite this as negative x squared plus 3x. And the reason that I want to complete the square is that everything that's an arc trig function is either like a squared minus u squared or u squared minus a squared or a squared plus u squared. Right, and we need a constant. We also need a quantity squared and then a constant. Okay, for this one, my leading coefficient has to be a 1, so I need to factor out a negative. And I'm going to get x squared minus 3x, leave a space. All right, half it, box it, square it. What's half of negative 3? Negative 3/2. All right, and then squaring it would be 9/4. Okay. Am I going to add or subtract 9/4 to compensate? I'm going to add it because there was a negative outside. All right, so this parenthesis right here is going to factor into x and then minus 3/2 because that's what I boxed. The quantity squared. It's, if you box a negative number, it's going to be x minus. If you box a positive number, it's going to be x plus. Okay, so I've got a negative variable squared plus a constant squared. Does that fit one of my arc trig functions? And a square root is involved. Okay, arcsine. What if would it be easier to maybe write it as 9/4 minus x minus 3/2 squared? Because then I've got my a squared minus my u squared. Okay, so I'm integrating 1 over the square root of 9/4 minus x minus 3/2, the quantity squared, dx. From something to something, 3/2 to 9/4. All right. Do you have to change it on this? Let's just kind of start working. I'm going to let you make that decision. What would u be? X minus 3/2. Du? Dx. A? 3/2. Good. If I can go directly to my arcsine formula, still using x's in my answer, then I don't need to switch my limits of integration here. And arcsine is arcsine u over a. So x minus 3/2 over 3/2. And then we're going to go 3/2 to 9/4. All right, so we're going to plug in the 9/4. What is 9/4 minus 3/2? So it'd be 9/4 minus 6/4, 3/4. And then divided by 3/2 would be the same thing as times 2/3. So it's 1/2, good. And then minus, when I plug in 3/2 for x, I get the arcsine of 0. So it's arcsine 1/2 minus arcsine 0. So what angle has a sine of 1/2? Pi/6, 30, pi/6. What angle has a sine of 0? 0. So your answer is pi/6.